Okay.
Yeah, I got too close to that terrifying pile of cables. Everything flicked. Terrifying pile of cables there. Just, I thought you did.
Order, I think, yeah, is, their ideas are more discussion in my updates, so I want to be able to contact them.
Thank you, Amy. Okay, can you go back to the agenda? Okay. Good morning, everyone, and welcome to the NTP Working Group at IETF 102. See, we have Marcus, Miroslav, Ragnar. Oh, good. We have almost all of our remote participants here. Nothing like a time working group starting a few minutes late. We have a very full agenda today, so hopefully we will keep moving. First order of business in an IETF working group. This is the note well. You will have seen it during the week. You will have acknowledged it when you registered. You will have acknowledged it when you registered remotely. Pay attention to the note well. So this is our agenda for today. We have already had a little bit of agenda bashing. So we will manually keep track of it, but we're not going to edit the slides because we now have this Chromebook that does the display, and I don't want to upload the changes, but we'll fix it. So we're going to move the enterprise profile discussion down to the point down later in the agenda when it's ready. And we are going to swap the NTS order of discussion, but I think other than that, we'll be fine. We're doing TICTOC first, and then we're going to be talking about the NTP working group items. We have a number of drafts in the NTP working group, and basically the objective of this meeting is to clear up a bunch of the items that have been hanging out there for a while. And as you can see, we have a quite lengthy agenda. So the first item was quickly, the first item is the TICTOC working group status. The only thing that I really wanted to mention here is that we have requested publication of the 1588 version 2 MIB. So it is in the publication process. I believe at this point, it's waiting on inter-area review. So we will keep track of that and keep you all updated of anything that changes. We will be skipping the enterprise profile for now, and we're going to move to Ignacio. So Ignacio is one of our remote presenters for today. Are you ready, Ignacio? I think he gets. I think he does the presenting, right? Are you there, Ignacio? So we'll troubleshoot what's wrong, what the problem is with Ignacio in the background. And my strategy to do the NTP, to do TICTOC first is not panning out, is it? So we're going to move to, yeah, I'll troubleshoot that in the background. We'll get somebody else started. So the next thing on the agenda was the NTP working group status. The only thing I wanted to mention under that working group status is we have submitted the NTP MAC document for publication as well. But folks can look at the data tracker and see the status of both of those. Next item I was going to talk about very briefly is the data minimization draft. The data minimization draft has been submitted again or published. And we don't have a presentation on that. I've spoken to the authors, and there has been, I have not followed up with the implementation experience, but there has been some implementation experience. The plan is to submit this for working group last call. Is there any opposition? Is there anybody who thinks that we should not submit it for working group last call? Okay, so we'll be doing that shortly. And now I see that Ignacio is online. Are you ready to go?
Yes. Yeah.
Excellent.
Well, good morning. I am presenting the synchronizing internet clock frequency protocol. This is an update. This is a joint work with, I don't know, I think it's not clear all the slide.
Yeah, we'll work on it.
It's a little narrow. Okay, now it's okay. It's a joint work with David Samariego, Alfredo Ortega, and Rudiger Greb from Deutsche Telekom. Well, next slide, please. The idea is that there are several applications that need some clock synchronization, but normally perhaps it's not well supported with the other synchronization, like measurements, crypto coins, localization, games also. Next slide, please. This slide tries to figure out where the protocols work. Imagine that you have some kind of RTT between your host and the server, and then different protocols have different error precision, or they can be also secure or insecure. Our proposition is in green. It's called SIG, and this provides frequency synchronization for very, very small error, about 10 of microseconds. Or if you want an absolute synchronization, is like NTP. Next slide, please. Well, the idea of our protocol, each packet is signed. Then we can explain better what security means. And the error is around 20 microseconds. It's based on traffic behavior. We just give frequency clock stability, and it's the model client server, simple software distribution. And if the exists asymmetric paths between client and server, you can use this synchronization like absolute clock synchronization, and it is related with another draft we are presenting in IPPM. The idea is to detect the symmetric path, and in this case, you can use this synchronization like absolute clock synchronization. We also produce a free available software distribution in GitHub. And well, next slide, please. Next slide, please. Okay. And the updates are a new author is added, Rudiger Greb, and we stressed the frequency objective of the synchronization. We also discuss some E2 related standard like the E2G 8260. We provide detailed information about security issues related with RFC 7384. And we provide also an appendix where we show some limitation of NTP because the deployment in some part of the internet, in this case, was in Buenos Aires, where in 4 parts of different networks at Buenos Aires, we show the different round trip time between the NTP server. This is all my presentations. Thank you for your attention.
Okay, so Ignacio provided this presentation in London and in here as well. We need to, first of all, the intention is to complete the existing working group items in TICTOC and close that group and move all of the time-related work into NTP. So the question is, and there is some talk about renaming or rechartering NTP, but I just thought it would be easier to get the remaining open items in TICTOC done. So the question is, from the 2 working groups combined, what do we want to do with this proposal? And if there's anyone, is there anybody here who else read this draft? Start with that. Okay, so a couple of you have read the draft. Is there anybody who feels is there any discussion of what should be done with this draft? I think at this point, Ignacio, it's been presented a couple times, and I think what we're going to need to do is, if you can work offline, I don't see any consensus right now to adopt this in the time working group and the NTP working group. Apologies. So I think what we're going to need to do is to build some more momentum behind it before we move forward with it. So I would suggest, if you were to post to the mailing list, that you are looking for collaborators to work on this and see if you can build a small community of people to help generate some momentum behind it. Is that okay?
Okay.
Anybody who is, I would encourage everybody to read this draft and to contact Ignacio for further work on it. All right.
Thank you.
Are there any? Were there any questions or comments? I guess I kind of skipped over that part of it. Okay. Thank you, Ignacio.
Thank you.
So the next thing we will move on to then is the guidelines for defining packet timestamps. You want? Do you want the clicker or do you want us to click for you?
Thanks. My name is Tal Mizrahi. I'm from Marvell. And this draft is a collaboration with Joachim Fabini and with Al Martin. And this draft has been around for a while, so I'm only going to give a very quick update. Next, please. Okay, the goals of this draft are two main goals. One is to define a relatively small set of recommended timestamp formats. And the idea is that if you're defining a new network protocol that requires a timestamp, you will typically be able to use one of these recommended formats. However, if you're defining a new protocol and none of these timestamp formats fits what you need, in that case, this draft also defines guidelines that specify how to define a new timestamp format. So these are the two main goals here. Next, please. The main changes compared to the previous version of the draft, first of all, the control field section. So this is a section that talks about control-related information that may optionally be attached to a packet timestamp. And if you remember in the previous IETF meeting, we had some discussion. We asked the working group whether you think that this section belongs in the draft or not, whether we should have it in another draft. And after asking the working group, after discussing this with the working group chairs, the decision was to keep this section as part of the draft, but to keep it focused on the purpose of the control field, on the main requirements, and to leave the detailed specification for a future draft, which we will publish in the future. So the control field section was significantly revised. It's now more focused, and we believe it's ready. Other than that, there were various comments made in the previous IETF meeting on the mailing list, and we believe we addressed all these comments, including comments from Greg Mirsky, from Yaakov Stein. So when we published the current version of the draft, we actually received some more comments from Miroslav, from Varner, and we plan, there was nothing major there. We plan to address these comments hopefully in the working group last call. Next, please. Which brings us to the next step, and hopefully we believe that we are ready for working group last call, and hopefully we can do this very soon.
Any questions?
The current draft doesn't seem to address the thing that I was hoping to get out of it when I voted for its adoption, which is that I was hoping we could come up with a binary timestamp format which addresses the problem with semantic ambiguity while leap seconds is in progress. Is that are we on the 60th second of this minute or the 61st? Do you have any thoughts as to how that could be addressed?
You mean a timestamp format that addresses specifically the leap seconds?
Yeah. So right now we're counting seconds since an epoch. It's not the draft doesn't discuss at all whether we're counting all seconds or counting non-leap seconds, and how we go about translating that count into an actual time.
So I'm not sure whether you read the most recent version of the draft, but there's actually a subsection about leap seconds. It discusses whether leap seconds affect the timestamp format or not. Again, this is a question for the timestamp format specification. Okay, wherever that timestamp format is defined, it needs to also address the question whether a leap second will address the format or not. Now, specifically for the recommended timestamp formats, we use formats which were already defined elsewhere: NTP format, PTP format. So for these formats, we're not inventing something new. We're only specifying them in a very accurate way.
Right.
Future formats, the guidelines in this draft tell you that you need to specify how the leap second is going to affect the timestamp format. That's part of the guidelines for specifying a timestamp.
Yeah, okay, but the current NTP formats are notoriously rather difficult to deal with that way. It separately requires a leap indicator bit outside of the format, and then even once you have that bit, 5905 is not exactly a model of clarity on what to do with it. So I think I think those issues need to be ironed out before we recommend these formats.
So just to make sure I understand, Daniel, I think what you're saying is that what you would like to see is a new timestamp format in which all that ambiguity around the leap second is resolved.
Mm-hmm.
Is that what you're looking for?
Yes.
I see. Okay, so we'll need to think about it because at this point we didn't plan to add a new timestamp format beyond the ones that are already defined, and we had to choose the ones that are really the most common ones.
Yes, they're common, but what we're producing here is a recommendation, not something with historic status. And so, without resolving this issue, I don't think we're making a good recommendation.
So, just by the way, the PTP timestamp format does not have this issue around the leap second, right? Because it's defined, the epoch is it's defined in TAI, so that means that you count the number of seconds regardless of the leap seconds, right? But I think that the way I see it, this is more a question to the working group, whether you think that beyond what we already defined, whether you think we should add a new timestamp format that resolves the issue that Daniel presented here. Thanks.
Any other questions on this draft? The question on progressing it within the room, how many people have read the draft? Okay. So on progressing it within I'll ask again on the list, I guess, but how many people within the room are ready to send it to working group last call? And those are who aren't? Okay. So we'll take this discussion to the list. Dennis, you were just going to give us a quick update on where the BCP is?
So right now the BCP is being reviewed by the Internet Area Director. That's what INTER is, right?
Yeah, that's what
Yes.
INTER is.
Okay. And so the review was conducted. They found several minor points which we can resolve easily. They did bring up something that was brought up here. I think Daniel may have brought it up in that the draft as written does rely very heavily on NTPD. And when Daniel brought that up, we pointed out that part of the reason for that is that the draft was written, all the submissions concerned NTPD, and one of the main motivations for the draft was documenting some of the security best practices from some vulnerabilities that were found a few years ago. So we do stand by the content of the draft, but Dieter and I have been taking some of the implementation specific things and putting them in an appendix. And so that's something that Daniel pointed out we might have to do anyway. So we were sort of prepared for it. And I actually think the format works a bit better now, because if someone were to come along and give us content for a different implementation, it's perhaps a bit easier to integrate that in the appendices. So Dieter and I have been editing that, and it's on the GitHub. And so this slide doesn't have a link to the GitHub, but I know I posted it on the mailing list reflector before. So you can see the current status of the draft with the edits that Dieter and I have made, if you're interested in looking at it. But I think from here, our task is going to be to work out with the inter reviewer, make sure they're satisfied with the changes we've made, and then it proceeds from there. Is that right?
That's correct.
Okay.
The one question for the group is if they're just comfortable moving the implementation specific stuff to an appendix. And I don't know if there's anybody that's uncomfortable with that.
I mean, we've had that suggestion before. We just didn't do it.
Just didn't do it.
And I didn't hear any objection at the time. So if there are objections to that, let me know. Let us know.
All right. And so you'll be following up with the reviewer on that, right?
Yes, we've already notified them of where the GitHub is, Dieter and I, and so I'm unfamiliar with what the timeline should be and how often we should bug them.
We'll be following up with our area director after this meeting. Unfortunately, he's not here this week because he has a family medical emergency. So, but we'll be following up with Suresh on a number of items, and we'll check in on this to see what the timeline is. Okay.
Just FYI, the IESG meetings are bi-weekly, so that's probably also a good interval to annoy them on.
There you go. That is true. The telechats, the telechats are announced publicly, and they are bi-weekly, and the agenda for those is published in advance, so you can see what drafts are on there. We'll be notified in advance when it comes up on the telechat. But there's for those of you who aren't familiar with the process, once it gets submitted to the IESG, the first thing that happens is the area director reviews it, and then before he submits it to the rest of the IESG. So this inter review is part of that process.
And so one point I'm unclear on is when we might be submitting another draft.
As soon as possible.
Okay.
Yeah, no, you should submit whenever you've got a set of comments. You should make the changes that you believe address that and submit an update.
Okay, the update will be submitted maybe not today, maybe tomorrow then.
Yeah, that would be fabulous. It would be better to do that.
Okay, thank you.
All right.
Anything else on this?
No. Any questions for Dennis? Okay. So, Brian, the working group last call status on the NTP.
Brian Haberman. So I posted a link to an updated document that I think takes into account all the comments that I received. I think I sent that note out Monday.
It was, Monday this week.
What day is it today?
Today's Wednesday.
Wednesday.
So.
Okay. So as far as I'm concerned, it's ready to go. So I will leave it up to the chairs to decide if how much time they want to give the working group to review it again, or if they want to make a consensus call that it does what it's supposed to be doing.
Okay. I believe the consensus of the working group in the working group last call was it was ready to be done. I believe you've addressed all of the issues that were raised in the working group last call.
There were no concerns about the actual content. There were really just some clarifications that people were looking for as to like the state of the document, why we were publishing it, and there were a couple of minor changes just to correct my inability to spell.
Your inability. Okay. The one thing. So is there any any opposition, I mean, it should have been expressed during the working group last call. I intend to submit this for publication as soon as possible.
Is this the control messages thing?
Can you go to the microphone if you don't mind?
Ask Hanson Apple. I was wondering if it was the control message thing. I wasn't paying attention.
Oh yes, it is the control messages thing. So.
To me, then it seems a very implementation specific thing. I don't think it makes sense to publish on this. There are other implementations who would want to implement it, if that makes sense. Otherwise, then it should just be in NTPD. Ask Hanson Apple.
It's Hanson Apple. Okay, so part of the motivation, first of all, we're publishing it as informational, and part of the reason for that was we didn't fully. It was covered in 1305, and it was not properly brought forward into 50. So it was more like a housekeeping thing.
Yeah, and there's actually text in there now that says this document is not intended to encourage people to implement this.
Yeah. So I think this document was originally introduced as historic and got changed to informational. But it seems to me that if we're going to be publishing it with that statement, then historic is the appropriate designation.
Well, now I know that the virtual queue is working.
Good morning,
ahead.
Harlan.
Good. Go ahead, Harlan.
Oh, okay. Mode 6 commands are supposed to be implemented by someone who does a full NTP implementation. Mode 7 was vendor specific, so the content of a Mode 6 stuff should be well specified and easy for anybody to implement. And that's about it. It isn't historic. Informational is fine, but it should be something that a complete NTP implementation offers.
Go ahead, Brian.
Okay.
So just I'm not sure how we actually have a record number of remote participants. So thank you all for calling in, or meetup going in, I guess. I do know that I recently changed it from standards track to informational because Brian pointed out to me it was supposed to be informational and I had mismarked it. So in the room, please hum if you believe this document should be informational. Excellent. And please hum if you think it should be historic. I have no idea.
And as a point of process, the hums don't take into account the people on the Jabber side of the world and the other 57 people who are on the mailing list.
Right. So I think what we're going to have to do is send this quick question to the mailing list. Brian, would you mind doing that? Or I guess the chairs need to do that. You're right.
No, I can do it right now.
You can do it right now. That'd be fabulous. You could do it right now, and people could speak up on the mailing list about what they prefer.
Make a decision before the end of the meeting.
This is Dennis Riley again. I do have a quick question because there is some content corresponding to the control messages in the BCP right now because people use them, and it's a good tool for monitoring. And so when I think about historical versus informative, my understanding was that it was documented in NTP v3, and it was left out of v4 more like an oversight.
It was an oversight, yes.
So when v5 is made, would you include it?
We've been having some conversations about how to clean up all of the, like how to move NTP to standard and in the IETF and to clean up all the documentation. But to say whether we would include it or not at this point, I can't answer that question.
So Dennis, to get back to your question, I'm almost thinking that the status of the command document makes no difference to what you would actually put in the BCP. I would think in the BCP, you would want to put something there that looks a lot like the security considerations that says, be really, really careful who you let send these things to your box. Yeah. So.
And we basically do reference that in the BCP, but we also say, these control messages exist and you can use them. My question is more from the perspective of, should this be historical? If it sounds like, maybe we'll get to that topic, get to that question later when it comes to V5. But it sounds like to me, if people don't view this as a core part of the protocol, then maybe it should be historical.
Yeah, I think it really depends on how people view it.
Right. I think this is a thing we'll take to the mailing list and back. I'll probably ask. This would be a good question for Suresh to ask him what his guidance would be. I think if it is in implementations and people are using it, then and it was left out, then perhaps it makes sense to go ahead and make it informational.
Yeah. My understanding is from at least the implementers that I've gotten feedback from is that some of them support it for legacy reasons, some of them don't support it at all. So while Harlan says that it's a part of the complete implementation of an NTP server, there's at least a couple of examples of NTP servers that don't support it. So
are there NTP servers that are not derived from the NTF code base that do support it?
Go ahead, Harlan.
The big gorilla supports it and uses it, so not mentioning that kind of does a disservice. If there are small implementations that don't support it or other things, that's fine and that's their choice. But it's there and it's an active use, and I think anything else I say would be a repeat.
Yeah, Harlan, I'm not disagreeing that that is not an active use. I think my point was more to the fact that there's at least one or two implementations that don't use it or don't support it. So
that's their choice.
Right.
So they're not NTP implementations then. They're not full NTP implementations.
I was kind of hoping for an actual yes or no answer to my question as to whether other implementations not derived from the NTS code base do implement it.
Right. So that's actually a good point. Is there anybody that can point to an implementation that's not the NTF implementation that uses this? So, Brian, when you're asking on the list, can you also ask if there's any other implementations beyond NTF? All right. Anything else on the Mode 6? I would like to thank Brian for his persistence on this. So the next thing is a chair's item as well. It's the Yang data model for NTP. The contributors to that document are not here. They have updated the draft based on all the comments they've received so far. They believe the next step for this is to ask for a Yang expert review. We could actually do a working group last call on it at the same time. My only concern is if you haven't picked up on this yet, my desire is to sort of clean out all of these small documents that are sitting around and get them processed. So we might want to hold off a little bit and let some of the other documents. We need to get some of the others through the administrative process. But I'm going to go ahead and ask for a Yang expert review now, and I'm hoping to target a working group last call maybe in August, but in any event prior to the next meeting. So any questions or comments on the status of the Yang? The next thing on the agenda is the interleave mode. Miroslav, did you want to just speak to that? If you want to pop in the queue, I can let you.
Hi, can you hear me?
I can, yes.
Just a quick update. There was a call for adoption recently. Nobody has objected, and the draft is now a document of the working group. A new version of the draft has been uploaded. There were 3 small changes made in the draft since the previous version. A diagram was added for the broadcast mode, so all 3 modes now have a diagram. The second change is supposed to handle a corner case incompatibility with old clients. The specification now says that the server must respond in the basic mode if the request has a transmit timestamp equal to the receive timestamp, even if the origin timestamp in the request happens to match a previous receive timestamp of the server and would otherwise look like a request in the interleaved mode. This will prevent a client that doesn't support the interleaved mode and is sending requests with transmit timestamps equal to receive timestamps from processing an interleaved response as a response in the basic mode, which would give it an incorrect offset and delay. I haven't seen a real client doing that, but I saw it in tests with randomly generated packets, and I thought it should be covered in the draft. The third change modified the check for duplicate packets from RFC 5905 to compare both receive and transmit timestamps. This is needed to avoid dropping a valid response in the interleaved mode if it follows a response in the basic mode and both responses have the same transmit timestamp. This can happen if the server doesn't always have a more accurate transmit timestamp after the transmission. I think there is not much work left to do on this document. The security considerations could probably be improved. If you have any comments or questions, please let us know.
First of all, can we get a show of hands on read the draft? Yeah. Miroslav, first of all, thank you for a very clear and well-written document describing the intent. But I think there are 2 serious problems in the proposal, both of which have the same solution. The first problem is that what you're proposing completely breaks in the presence of NATs. In particular, that the server tracks clients by IP address, but allows sessions to hop from one port to another. I think you get 2 different NAT problems depending on which decision you make on the port thing. If you do allow port hopping, then you get the problem that 2 clients on the same NAT will get confused with each other. If you don't allow port hopping, then you get the problem that once the clock settles, these packets are relatively infrequent, and the NAT box will forget about the session from one packet to the next and maybe assign it to a different port. The second problem is really more a matter more a matter of good design than a specific issue, but that I really dislike the idea that we're going to take these 2 timestamps fields and repurpose them to mean something completely different. And rely on implicit context to determine what they mean. This confusion has already caused numerous issues in the reference implementation, both it just not working and security wise. But that we can address both these problems in the same way, which is just put the information into an extension field. Keep the header fields meaning what they've always meaned, and add an extension field which carries one, an explicit session ID so that the server doesn't have to guess about NAT issues. And then after the session ID, the interleave timestamps. And just do that, I think it solves all our problems.
Okay, I think the first issue with ports is not really an issue. The draft explicitly says that the server should not track individual ports. So a client changing the port is not a problem. Two clients on the same IP address might be a problem, but if the server remembers multiple timestamps for the same IP address, and this is one of the recommended ways in the draft, that won't be an issue too. There might be a limit, I don't know, for the maximum number of timestamps kept for an IP address, but that limit could be as high as needed. And the second issue with reusing the timestamp field and the origin timestamp field, yes, I agree that it could be more explicit, the interleave mode in the packet, but considering that it has been used for quite some time and it's fully compatible with anything that could be on the path between the server and client, doesn't break anything by design. So I think that's one nice advantage of this approach.
Harlan?
Interleave mode was designed for symmetric mode, not client server, because the server isn't expected to remember state.
Okay, and this draft expands on that and defines the protocol for client server mode.
Okay. Any other questions or comments on this draft? Miroslav, can you update it based on today's discussion and ask for comments on the mailing list, please?
Thanks.
Thank you. So the next thing on the agenda is just a really quick, I wanted to highlight, at this IETF, we did a second hackathon effort like we did at the last one. And I think we made some interesting progress. Our basic plan was we were looking to get NTS into some different NTP implementations. We had, and at the time we were looking at two drafts, the -12 and then the Densari draft. And we were looking at verifying interoperability between various NTS implementations. So we had sort of a hodgepodge team, I'll have to say. So we had Martin Langer, who did the original implementation that we used last time. We had Daniel's implementation, and we had a young woman that showed up to work a little bit on that. We had a team. I will say we had a remote. We had a pretty distributed. We had a group in Sweden and a group and an individual in Germany, and those of us that were here. We had the team in Sweden working, and we had the Network Time Foundation folks working, and then we also had a young man who showed up to work on an open NTPD version of it. On the right are the various resources and documents and code repositories that we were looking at. This is sort of a very kludgy diagram of what we have. This is a chart that basically shows what we got done. And we being the royal we, because everybody else did the work. I just sort of watched them and wrung my hands occasionally. And then this is a high-level summary of what we did and what we learned. So we not proved, I guess this is something everybody in the IETF knows, that interoperability tests are indeed important. We also ran into some issues that the NOC was able to troubleshoot. And I think one of them is going to be an issue just deploying new kinds of technology based on NTP going forward. We had some sort of interesting filtering where packets were going, NTS packets were successfully going to Germany, but they weren't getting back. So somebody along the line was filtering them. The original comment that we got was the IETF network is filtering NTS packets. And I'm thinking to myself, I don't think so. And after a bit more troubleshooting, they set up a tunnel from here to there, and it worked fine through the tunnel, but not outside of the tunnel. It would go in one direction, but not the other. And even if you switched directions of the client and server, you still had the problem from Germany to the U.S. So, and in a lesson that you don't have to teach anybody here, I guess, is that Wireshark is your friend. So anyway, I think these kinds of activities are really helpful to sort of gather momentum and see what people are actually willing to spend time on. We have a very rough thought in the back of our head about possibly doing something, virtually, or a small group in person in Europe in early October. It's just a thought at this point, and I'm not sure what we're going to do yet for the next IETF, because we will be in Bangkok, which is I'm not sure, what we're going to have at that point. But I would like to continue seeing some public working and public testing. So with that, the next thing we're going to do, we're going to swap the order on the agenda, and we're going to go to I keep calling it Densari, but he actually has a real first name that I'm not using. So, Marcus. There we go, Marcus. Yes, I keep calling you Densari, and I know that's your last name, not your first name. So, are you ready to present?
Yeah, I hope so.
Excellent. Go for it.
All right. I'm assuming you can hear me.
Yes, you're quite clear. Thank you.
Great. Good morning, everyone. I'm Marcus Densari, and it's me and Ragnar Sundblad, who's also participating remotely, who authored the suggested improvements to the NTS drafts. And I would just like to start by thanking everybody for this opportunity to present our suggestions. So slide, please. So as I mentioned, my colleague Ragnar is the main designer and operator of the Swedish IX NetNodes NTP service, which they run on behalf of the Swedish Post and Telecom Agency, PTS. It consists of 8 high-speed Stratum 1 NTP servers designed from the ground up to be highly resilient, and each of them can handle NTP requests at the full line speed of 40 gigabits per second. They are placed at 4 of NetNode's secure IX points, and a 5th point with 2 additional NTP servers will be set up soon. NetNode currently offers authenticated NTP with existing symmetric means on request, but would of course like to offer authenticated NTP to everyone. Slide, please. Next slide, please. There we go. So in the interest of time, I'm only going to mention the most important changes we made to draft 12. And the last slide of the presentation will contain a link to a diff between the differences. The most important change we made is the separation of the NTS key exchange and NTP servers. This allows a single key exchange server to provide cookies for any number of NTP servers, which in turn enables support for a number of different features and infrastructures. A new NTP server negotiation NTS record allows the server to forward the client to an NTP server after receiving the cookie. A secondary feature of this record is that the client can also request cookies for a specific server or servers, although the NTS key exchange server may choose to ignore the client's preference. We've also changed the requirement of TLS 1.2 to 1.3. This is since RFC 8446 should be released any day now, and TLS 1.3 will probably be in relatively wide use when the NTS draft becomes an RFC. Furthermore, the NTS authenticator and encrypted extension fields have been changed to simplify implementation in hardware and FPGAs. And we also believe the new format to be easier to understand in general. And finally, the addition of the requirement that NTS implementing servers always include the unique identifier extension field in responses will allow clients to ignore spoofed kiss of death packets from off-path attackers. Slide, please. Next slide. Sorry, one back.
Go back.
Yeah, my bad, sorry. So to summarize, our suggested improvements will allow for the use of NTS in multi-server infrastructures, increase the general resilience of the NTP and NTS infrastructure, simplify FPGA and hardware implementations, and increase protection against off-path attacks. All right, on to the last slide. There we go. So just to close up, I'd like to thank everyone who worked on the previous drafts on which our improvements are based. And the link and QR code you see here will take you to an RFC diff between our draft and draft 12. So thank you all for your contributions to NTP and NTS and for your attention. Yeah.
Okay. Well, that was quick. So are there any, so how many people have read this draft? Daniel. Okay, excellent. So are there any questions or comments, or how do we want to, I'm looking at Daniel here. Do you want to?
I have quite a few comments, most of them positive. The reason that I wanted to swap the order of our two presentations is just so so that since we're on tight time, I want to use my presentation time to respond to these proposals.
Okay, so at the end of this conversation, I want a pretty high-level understanding of what part of their proposals are being accepted and what ones aren't. And so we're going to get to that point then? All right, so then you're up. You don't have slides though, right?
I've got them, but I'm probably just going to skip them.
Oh, okay. Oh, did you want to say something, Doug?
Doug Arnold from Meinberg. This is just really a general comment to this group. Meinberg builds NTP servers, and in that context, I talked to a lot of network operators who continually express frustration that there is no security solution to replace AutoKey, and would be happy to have something that works for 80% or 90% of the cases rather than trying to make a perfect solution. So I just thought I'd remind everyone of that. I actually forgot to pay attention to the Jabber room. Actually, at the very beginning of this, I neglected to name a Jabber scribe. So I remembered this, and then I was trying to do it myself. So there's Danny Meyer from the room asks, have you considered the DTLS connection ID that's now in the draft mode, draft Frescola TLS, DTLS connection ID?
Is that a question for me?
A connection for you, or for, I guess I could also ask Daniel as well, but I guess all of the DTLS portions that we had in here were removed.
We saw that they were removed in previous drafts, so we didn't want to steer back to something the working group had already left.
Right. Okay. I think it probably wouldn't hurt for both sets of you all to take a quick look at that, just so we can properly answer that question. Daniel, do you want to go?
So could you just flip back to Marcus's slide on what the changes are? There we go. After speaking with my co-authors on these proposals, I think I am speaking for myself and them, but not necessarily for the working group as a whole. So I'm going to address these in roughly reverse order. On On the always include unique identifier thing. No objection to that. In fact, I think it was an oversight on my part that is not already in the document. On the change in the format of the NTS authenticator field. So this change was proposed to us in the context of reducing the number of gate equivalents necessary to implement this in an FPGA. And I just want to say thank you for bringing this up, because while I have played with FPGAs, I am not by any means an EE, and this would never have occurred to me. I intend to accept this change, and I'm happy that somebody. I'm happy that somebody brought this up before it went to the IESG, because nobody on the authorship team would have ever thought of this. As to the proposal to require TLS 1.3, we do think that's quite a bit premature. TLS 1.3 is has some implementations, but is not yet widely implemented. And even once it is widely implemented, it's going to take another few years for that work to make it into OS distributions. So as much as I would, as much as I hope that within a few years everybody has moved to TLS 1.3 anyway, I think that putting in a requirement now is going to inhibit NTS adoption. On the proposal for the separation of NTSKE and NTP servers by adding that negotiation record, my first thought on this is that this would be something better to do in DNS SRV records rather than as part of the protocol. Ragnar talked me out of that and convinced me that this approach is better. However, I have a slight objection to the current form of it, wherein this record provides an IPv6 address, which may be an v6 mapped IPv4 address. That record should instead provide a host name string, something that you can pass to get adder info, and there should be a complementary record for a service string. So if you don't get the host string, then the default is to contact the NTP server at the same place as the NTSKE server, and if you don't get the service string, then the default is to use port 123. With that, I'm just going to go ahead and take questions and responses.
Martin Levy, Cloudflare. Sorry, I was trying to look up the exact URL, but there's some pretty good library support for TLS 1.3, and we do that. I'm just trying to find the blog entry that we did that sort of talked about the different implementations. So if you think about this as being libraries that can be easily found and added to a code base, then 1.3 doesn't seem to be that much of an issue. And this isn't meant to be accessed directly from a browser, but from libraries. So therefore, it's far more likely to go to one of the applicable libraries and then move forward. So I politely disagree. And I know I need to then send some proof into the mailing list for this.
Mm-hmm.
Leif Johansson, full disclosure, I'm affiliated, but not with the guys who's done this, but not directly involved with the project. So I was going to try to argue both sides of the TLS issue, just for fun. So I can actually see your point. I think it's very likely that when you deploy something like this or distribute something like this, you're gonna rely on the operating system TLS stack, and the choice of TLS 1.3 or 1.2 is going to largely be a configuration issue in practice, right? So nailing this to a specific TLS version is I'm not entirely sure it has a lot of, it's going to have a lot of impact in practice if you write it down in the spec. Now, on the other hand, right, there some people who were present on Monday, there was a presentation at the ANRW conference on privacy aspects of long-running, TLS connections, long-running protocol associations between client and service that include some sort of unique identifier. And there was a point made about NTP specifically at the mic. I don't remember who made it, right? But the point was that this sort of thing was a lot worse in TLS before TLS 1.3 when we figured out how to encrypt all of the relevant traceable identifiers. And that I think it might be a good idea to actually go back and investigate, what, if any, is here. Because TLS is one of those things, NTP is one of those things that you can't really not have running. And it will be, it's one of those things that can actually provide an attacker with, or somebody who's fingerprinting you with lots of information.
Mm-hmm. So I think we've I'm pretty sure we've taken the privacy issues into account. Right. when I designed the cookie scheme in NTS, I was quite deliberately copying what TLS 1.3 does with session tickets, and then for the basic parts of NTP, for the non-NTS parts of NTP, that's what my data minimization draft is for.
All right, that's excellent, right? In that case, maybe that part of my argument is moot. In that case, I'm still sort of, in practical terms, I think the implementers, even if you read a spec that says must use this or that version, right? In practice, that's going to be configuration.
Mm-hmm.
Brian Haberman, and just to kind of, I don't know if I'm reinforcing what Leif just said, but I double checked with a couple of people. TLS 1.3 is already seen in implementations on the internet, and you're not really trying to deal with backwards compatibility with an existing implementation that might be using 1.2. So 1.3 probably is the right way to do it, because
you could write that as a recommendation. It doesn't have any effect, right?
Yep, right.
Hello, Jean-Philippe. In the privacy considerations about unlinkability, right?
Mm-hmm.
So one of the concerns that I had was that the client is not unlinkable from the perspective of the server.
Mm-hmm.
And absent any good ideas to actually resolve this problem, I would at least like to see some clarification of the threat model in use here, and a note in the privacy consideration section that you are not unlinkable from the perspective of the server.
Mm-hmm.
Obviously, I'd like to actually solve this problem in the long term, but I don't have any good ideas for how to do that right now. So just making that explicit would be nice, I think.
If you want to submit text on that, I'll definitely merge it. Otherwise, I'll try to remember to put something in myself. Also, as far as actually being able to solve the problem, we discussed this in the hall yesterday, and the conclusion is that it is quite difficult. Probably some sort of blockchain thing needed in order to enforce that. That everybody is being handed the same private key, the same public keys, that you can't discriminate between them that way. Almost certainly not going to be resolved in this main document, but maybe something of interest for future extensions.
Sure. And then a question to people implementing highly scalable NTP server offerings. One thought on avoiding unlinkability is to do key exchange more frequently. That has performance impacts, and I'm curious if anyone has any comments on what might be some appropriate, maybe recommendations or something about a key exchange frequency that might be appropriate for people who wish to provide unlinkability from the perspective of the server. So that's an open question to the group, I suppose.
As Kenton, just because nobody else mentioned it, I'm very much in favor of the changes to separate the key exchange from the NTP server. In particular, for my hobby project is the NTP pool, and we have, I don't know how many NTP queries it's taken, but it would be nice to be able to support them with NTS.
Okay. So, what's your thought now on that, or do you? Or should we take it to the list?
Yeah, let's take everything discussed here to the list.
Okay, take it to the list. So the logistics piece of this, though, the draft, the Densari draft, you all will do. Did you want them to do pull requests, or were you going to?
Yeah, that would be helpful to have it have the issues broken into pull requests,
Okay.
so that we can track commentary that way.
All right. So this the base NTS document is in GitHub. Marcus, are you all comfortable taking the suggested changes you all have and doing pull requests on the base document?
Sure, we can do that.
Okay. If you guys could work with Daniel and the authors of the core NTS spec, that'd be great. Thank you.
Yeah. Thank you.
Did you have anything else you wanted to say about the 11 to 12 update?
No, not really.
Okay. I just would note that the 11 draft is the one that we looked at in the context of the hackathon in March, and 12 represents the lessons learned from that hackathon.
Mm-hmm.
So, all right. Any other questions on that piece of the NTS work? Okay. What I'd like to do now is to go back in time and pick up the PTP profile, if that's okay. Thank you. Thank you, Daniel. Doug? It's the first tab. So this is back to the TICTOC working group, and this is the enterprise profile that went out for working group last call. I think it was the second working group last call. And Doug is going to talk to all of the changes.
Okay, so went out for last call. There are a number of comments, mostly little things like grammar that needs to be fixed due to cut and paste errors or whatever, and also a couple of things that were asked to be clarified or explicitly mentioned. Nothing that changes the way the protocol operates. So I think we can address all these. Okay, one thing that was suggested by Karen actually is to add into a statement to this effect. So there's a section 4, which is a problem statement, which is the first section where we say we're defining a PTP profile. And I'm going to add this statement: interoperability among independent implementations of this PTP profile has been demonstrated at the ISPC as Plugfest. So the last, and I'll have a slide on that later. The last 3 Plugfests, we've demonstrated this is with as many as 9 different organizations having implementations. At one point, unicast discovery and negotiation was an option, and a discussion among some of the implementers at the ISPCS, we decided to remove that from this profile. So that we'll add in a statement explicitly saying that it shall not be used. There was a question about in the PTP, every message carries a log base 2 message interval indicator. And it was suggested that in a delay response message, rather than having the normal 7F, which is generally used for unicast in PTP, as a value, it's when it means is if you see a 7F, that means the rates have to be negotiated. But since we're not negotiating, we'll give the option of, instead of putting 7F in, the master port could say, this is the rate I'd actually like to have messages at. A couple of things that should be added to the security considerations section. One is we want to add a citation to this RFC, which describes, a lot of the different threats and mitigation, general mitigation techniques that can be used in networks. I think that's very worthwhile because it's tailored towards time protocols. So we're going to add that in. And also a comment was that we should discourage the use of PTP native management messages since they do not have a security mechanism built in. They're never going to. And instead recommend using a standard management mechanism that has security, for example, netconf, and it's just an example, but I'll add a citation for that. And then there's several nits that were just little things that were grammar. You can look at these slides later if you want. They're just little things like punctuation. So those things we can all fix. This is a slide from one of the ISPCS plug fests, where we test various PTP profiles, including the enterprise profile, and it has been tested on 3 continents over the last 3 years, and will be tested again at CERN this year in the fall. And we tested both IPv4 and 6 multi-domain operation, hardware and software, commercially available and open source. Quite a variety of things have been looked at. So that's all I've got. Any questions?
Any questions? Okay. I think based on the working group last call, there is working group consensus to move this document forward. Do you have a time frame for when you are going to submit the changes?
I can do that within the next couple of weeks, I think.
Okay. As soon as you get that done, we can go ahead and request publication.
Okay, great.
All right. Thank you. I know this has been a bit of a long time coming. So the next thing I'd like to do, now we're moving back forward in time. It's kind of funny, actually, given the next presentation. Netta? So this is, she can introduce the work herself. This was presented, was one of the papers accepted to NDSS in February, and it was presented again at the Advanced Networking Research Workshop on Monday. So, welcome.
Okay. So hi, I'm Neta. Thanks for the introduction. And I would like to present a work on how to protect NTP. It's a joint work with Omer Deutsch, Danny Dolev, and Michael Shpira, and we also collaborate with Tal Mizrahi. So I will get things to speed. I guess you all know that we're going to focus on 2 of the processes in the NTP: the pull process, where the client gather time samples, and the selection process, where he select the best time. However, we know that NTP is highly vulnerable to many individual attackers that can tamper the NTP response. You can also change the client time by simply dropping on delayed packets to from servers. That is why authentication here is insufficient, and previously studies even considered when in the middle is too strong for NTP. But why is so vulnerable? If we focus on the pull process and the selection process, so in the pull process we rely on small number of NTP servers, and they're often DNS cache, which means that the attacker only needs capabilities, many limited capabilities with respect of few NTP servers in order to maintain his attack over time. And in the selection process, algorithm, they assume that accuracy are rare, and most of the NTP responses are well distributed around the UTC, which means that powerful, sophisticated man-in-the-middle can bypass these algorithms. And he's behind a scope of traditional treat models. This is why we propose a modified NTP client called Chronos. With provable security, we can bound the probability of a successful time-shifting index, even made by a middle attacker. It has backward compatibility, since there is no need to change anything in the server side, only limited software are needed in the client side, and it adds only low computational and communicational overhead, since we eventually query only few NTP servers. So in order to prove that Chronos protect NTP, and we need to define the treat model. We assume that the attacker here has fully control over a large function of the NTP pool, say quarter. That is why he can decide both the content and the time when the responses are going to arrive to the client. And of course, we assume that he is malicious and try to make the maximum time shift he can. So how Chronos is built? On the one hand, we rely on many NTP servers. We generate large pool of existing NTP servers in order to raise the threshold needed by the middle attacker. On the other hand, we query only few of them that are randomly choosing every update around 10 in order to avoid overloading the NTP servers. And finally, we use smart filtering in order to remove outliers and make it hard to the man in the middle to contaminate the chosen time samples. So informally, I will describe how the client updated his clock. So out of 100 of servers, M10s are randomly chosen, and they are ordered from low to high, and then we remove the the lowest and the highest samples, and take a look at the remaining set. And then we check. We have two conditions. First, are the remaining samples close to each other, and if their average, which we value used to update our clock, is close to the client clock. If these both conditions are satisfied, then we can update our clock according to their average. Otherwise, we will try again. We will sample. And again, out of 100 of servers, 10 are chosen randomly. They are dropped from each side, and we focus on the remaining set. And if we fail, we try again and again and again until we fail k times, and then we move to the panic mode where all the servers are queried. We drop outliers and take their average as the new client's time. So first, I'm going to introduce the security guarantees, and then I will describe the security analysis. So basically, what we are showing in our paper is that shifting time with Chronos for even 100 milliseconds from the UTC will take the attacker at least 20 years in expectation. And this is when we consider in the extreme case where we have 500 servers, but 7 of whom are fully controlled by the attacker. We also assume that we can query 15 servers per hour, and that good samples are within 25 milliseconds. Look at, we will denote this as omega, and the parameters of the number of servers we can achieve in the pool, and the distance of good server samples from the UTC. It's was shown in the experience that we conducted in Amazon servers, both in Europe and in the US. And here we can see the benefit of using Chronos over the current NTP as a function of the number of servers that we query per hour. So, for example, if we will focus on the last scenario where we have 500 servers and 7 of whom are full control by the attacker, then we can see in the purple line that even if we use 8 servers per hour, and then instead of query 15, we still get improvement of in the factor of 100 compared to the current NTP. And now I will describe the security analysis. So out of hundreds of servers, M are are chosen randomly and they are dropped from each side. So when we are looking at all the scenarios that can happen and take the worst case scenario in any scenario, these scenarios are going to depend on the number of malicious servers that were queried. So the first scenario is when the number of good samples is equal or less than D, and the number of bottom samples is higher than M minus D. So in the worst case, we have only malicious server in our remaining set. But according to our second condition, their average that we use in order to update our clock should be close to the client's time, which means that we bound the maximal shift that we allowed in Chronos client. And we have to know that this scenario probability is extremely low, since we required malicious server to be randomly chosen in much higher rate than the rate in the population. And of course, repeated shift is negligible. That is why we can say that significant time shift here is infeasible. The second scenario is the opposite one, when we have more than D good samples and less than A minus D bad samples. So the first option is that we have only malicious server here in the remaining set. However, we have more than D good samples, so we have at least one good sample in each side. Good samples are omega away from the UTC, which means that the remaining samples are omega away from the UTC, and their average is omega away from the UTC. The second option is when we have at least one good sample in our remaining set. However, according to our first condition, all the samples in the remaining set should be close to each other, which means that again, we have one good sample, omega away from the UTC, so all the samples should be close to the UTC, and their average that we use in order to update our clock eventually it will be close to the UTC. This is why we can say that these strategies are ineffective. However, maybe we can do some other things. Maybe we cannot shift the time, but maybe we can create a data attack. So we try, and we saw that in order to do so, we needed more than D bad samples, so that at least one bad sample will be in our remaining set, and can violate one of our conditions and cause us a resample. And resample again and again will be it will cause a panic attack where we query all the server in the pool, and maybe multiple panic modes for multiple Chronos clients can create a DDoS attack over the NTP servers. However, we saw that even if we are setting a low panic threshold, which means that only after 3 times we move to the panic mode, the probability of successful of shifting one NTP client is negligible, which will take the attacker years to cause us to move to the panic mode. Another note that I would like to add is that there are scenarios where we don't have a lot of servers in the pool, and then a Chronos scheme can scheme on the entire pool and yield the deterministic security guarantees instead of probability scheme. And this kind of sum up the differences between Chronos and the Chronos NTP. And Chronos is based on pre-processing, where we gather all the existing time NTP servers, in order to then choose randomly all of them, while the current NTP say queries to the several NTP servers. And the selection process, instead of applying Marcel algorithms and try to select the best samples and or a group of good and high quality samples that are kind of close to each other. What we are doing is we are removing D from each side, and then both algorithms basically take their average, but the average of the remaining set, but why Chronos is updated the clock only if the average is close to the client's time. The current NTP updated the clock only if it's far from the client's time. And so to conclude, and we noticed that NTP is very vulnerable to time shifting attacks, especially made by man-in-the-middle. It wasn't designed to protect it, and from strategic man-in-the-middle. So we present a Chronos NTP client with probable security, backward capability, and low computational and communicational overhead. This is for the research subject. Thank you, and this is a link to our paper.
Questions?
Hey, taking as a baseline assumption that all our traffic is authenticated with NTS or whatever else, so that a man-in-the-middle adversary can drop or delay it, but can't forge it. Existing NTP algorithms already have an upper bound on how much a man-in-the-middle attacker can shift the clock, and that is because so we're we can get a maximum error out of the protocol, which is basically 1/2 the round trip time. And the max dist parameter built into the NTP algorithms specifies how large that round trip time can be before we reject it. I think in RFC 5905 it's 1 second. I think the NTF implementation has changed that to 1.5. But anyway, there's already an upper bound there. So if we go with the max dist is 1 second, then that upper bound is 1/2 second. I don't quite understand how Chronos improves on that bound in the man-in-the-middle case. If a man-in-the-middle is delaying all your traffic in one direction, so that everything comes back in just under a second, then does Chronos still get time with an error smaller than 1/2 second?
First of all, we hope so, and this is exactly what we're studying right now to see really what the accuracy that we get in a certain scenarios. However, according to what you were saying about NTP have a sort of threshold, so there was a work in 2016 by Sean Goldenberg that showed that you can shift the NTP clock by 1 year by attack, and you don't need to be man-in-the-middle attacker just to attack for around 100 days. So it's true that we have this threshold, but I'm not sure he's. I mean, what we are trying to do here is to elaborate it, to basically to add another layer to the NTP that it will be more protected in the scenario.
So I may be remembering the wrong one of Sharon's papers or remembering it incorrectly, but I could have sworn that that those attacks that gave you those big shifts were all exploiting implementation bugs. And so it remains my belief today that when everything is correctly implemented and that you have and that a majority of responding servers are honest, that you get the 1/2 second upper bound on clock shifting.
I think the main difference is whether you update your clock when you're too far than what the servers are telling you, instead of and this is mean that you believe them, and I think this is why. I mean, I understand that it was designed to get a high precision, but it can also. This is the floor, and I think it's. I mean, I know that part of the work that have been done on this subject really look at implementation flaws, but I think that there is more to it, because maybe we can add another point of view that's saying we are not automatically taking out of 4 or 6 NTP servers and allow them to shift us for long time, for a long time. I mean,
So if you if you're dealing with just a minority of dishonest servers, then then I do see how Kronos gives you some improvement, be it to get bounds tighter than half a second. But I'm not convinced that it does anything when you're dealing with a man-in-the-middle attacker or a majority of dishonest servers.
I think that the problem is not half a second, because it's half a second over time.
Mm-hmm.
So I'm not looking at. I'm looking at how far can you get, and in the current NTP, I can shift. If I'm the attacker, I can shift the time by tiny steps, maybe, but for a long time. So eventually, I will succeed to make a huge time shift.
Go ahead, Doug.
Doug Arnold from Mindberg. Just a couple of comments I want to make. First of all, real networks in the field are full of implementation errors. We try to close them up as much as we can, but they're out there. The other thing is real networks have all kinds of things running besides NTP. So when we look at how impervious to man-in-the-middle attacks we need to make it, it only has to be less trouble than other key protocols that are running. We'll never make it, perfectly impervious. So I tend to agree with the last commenter that NTP might be good enough already because it has a redundancy that a lot of protocols don't have to man-in-the-middle of attacks.
Well, I suppose that I can understand why. I think that we should do our best to secure protocols, both NTP and others, this is why I come to present.
Let me get some of our virtual queue people in here. Yakov?
Hi, you hear me?
Yes, go ahead.
Oh, great. First time I'm using it, this IETF. Okay, my question has to do with the trade-off between security and timing accuracy. Simply, yes, it's very important to be secure, but many of us are using NTP to get highly accurate time. And obviously, NTP has mechanisms in addition to the mechanisms for throwing out popcorn and et cetera, things to measure dispersion and to weight different servers if you're using a pool of servers. And once we do something very simplistic, like looking at each server for a short amount of time and jumping between them, or doing simple averaging, we're losing a lot of the mechanisms that we do to get very, very accurate time.
That's right. I know that in order to get frequency and delay, you usually take 4 updates to, for example, for each time sample for each server. So what we are studying right now is how we can combine this, how we can both use Kronos and still have we will be able to be both precise and accurate. So
no, you won't be more precise because you're not estimating the particular path between the client and the server over a long enough time for any particular server in order to get the real minimum of the delay. So you're going to be hitting it. I'm just wondering if you made an experiment where there were no man in the middle, no bad servers, and just check to see what the performance hit is.
Yeah, we expect that this protocol to be sort of suboptimal in a currency. This is why we would like to present this work and try to combine it within the current NTP, and not just to say instead of all the selection process, we are going to change it all by just adding Kronos. We would like to add Kronos to the current NTP in order to maintain the precision and the accuracy that we get from the current one.
Ignacio? I guess I didn't give you a
Hi.
chance to respond.
Yeah.
All right.
Just a simple question. Do you use always the same server? I mean, if all work well, do you continue to use the same server?
Yeah, this is a part of our further work that maybe we can weight servers according to their reputation. This is exactly what we are trying to study now. If we can give them grade or weights, and then we can maybe continue and query some of the server or over time. So yeah.
Okay, just because if you are changing the servers, it could be get more error in every time calculation. It's more or less related with the question about of Jacob. This is the idea, because if the time change and okay, you have traffic into the network and so on. This is my comment about that. Thank you.
Thank you.
Harlan, quick, please.
Sure. The slide about comparing Chronos with the current NTP architecture, it looks like you folks didn't look at the behavior of the pool directive, which spins up to 10 associations, and as the algorithms decide a server might be pressing the bounds of reality, it throws that server out and solicits new ones. So I'm trying to see how what you're proposing is better than what the pool directive does, because that's also going to keep servers around for as long as they behave properly, which will get your dispersion numbers lowered, and it will automatically weed out outliers. And the other aspect of that is the pool project itself will monitor the time on the servers, and if they see that a server is misbehaving, they will drop it from the DNS list, and we requery that. The implementation requeries the DNS list to see who the new servers are. That's it.
So again, if I understand correctly, you're saying that if we do weight servers according to their reputation, then we will be less protected than because we repeated on a certain amount of servers over and over again, like the current NTP. This is what you're.
I'm not sure I would use the word reputation there, because we're not using servers based on their reputation. We get the pool will offer servers based on reputation, but once NTPD has them, it selects which ones to use based on actual performance. And if performance begins to deviate, those servers are thrown away and new servers are solicited, and that happens dynamically. So there's the ongoing monitoring the pool does, which says whether or not a given server is even going to show up in the pool. And then once the pool members are selected by a given NTPD instance, that instance decides which of those servers to pay attention to and which ones to ignore.
Yeah, but within the current NTP, a lot of checks that we do, like the jitter inside the servers, etc. This is something that if the attacker knows our algorithm, he can play with it. I mean, in our scenario, the attacker have full control over the NTP servers, a fraction of them. And what we suggested is, okay, still look at the jitter and the stratum and another checks that the current NTP does, but maybe even if certain server passed all these checks, maybe you can still identify it as an attacker if he is.
Why don't we take this discussion list, if that's okay? I'm going to go to the queue in the room, and I'll come back to you, Yakov, if that's okay. Go ahead.
As Kansen, I guess in this context, I maintain the NTP pool. I think it's a lot of fun when people do work like this. Nobody ever tells me before, and I'm happy to give you a server list, for instance. So if any of you hear people who are working on this sort of thing, I'm happy to help figure out how to make it better. I think Harlan's question was sort of related to what I was comment on, that it's not you both. The man-in-the-middle attack is possible, but the other attack that's possible is just a bad actor. There was someone else writing a paper earlier this year, I think, about that, where you have a bad actor joining the NTP pool and pretending to the monitoring system that they are a healthy server, but pretending to certain clients that they're not. And in most countries, I think, right now how it works in most countries, what Harlan described with the pool directive and what Dennis, I think, said before with the built-in NTPD stuff would sort of just work. But in some countries, there are very few servers, and something like what you were describing with Kronos would absolutely help keep time accurate. And thank you for doing the work. It's fun.
There you go. Doug?
Doug Arnold Meinberg. Yeah, thank you as well. This is very interesting. On the subject of accuracy, certainly changing servers frequently is going to add a certain jitter to the server loop, but it might also help average out some quasi-static or static asymmetries in the network. So it might be something to think about.
Okay. Okay, Yakov? Sorry, can you, let me get Yakov, sorry. And then you can go ahead. Yakov?
Okay, it'll be shorter because I had one remark that I wanted to talk about the weighting according to reputation rather than according to accuracy, and that was already discussed, so I can take that one off the list. Just one last remark, and that is about the extensions. Take into account that if you're going to be looking at 1588, in certain applications of 1588 where we need high accuracy, it can take literally an hour or more and with looking at a particular connection until the accuracy gets into the area we want. And if you're going to be looking for a short amount of time and jumping to a different, well, there it's not client server, obviously, to a different connection, you're not going to get anywhere near the accuracies that we're talking about unless you do one big PLL and look at all of them and weight them all and somehow do something very, very sophisticated. And I have seen such an algorithm in the past, and perhaps actually if you're here, right now I'm sitting in Jerusalem, by the way, so maybe sometime I can just jump over and we can have a discussion.
All right, thank you, Yakov. And
on all these accuracy issues we've been discussing, I don't think we're going to get anywhere at all by arguing about them. This is a place where there is just no substitute for some empiricism.
Yeah, for some. All right, so all right, this is the last comment on this document. Go ahead.
I'm wondering if you have thoughts on best practices for bootstrapping the list of the set that you choose servers from, because the security bounds are not just, NTP is not the only thing within your trusted computing base for this system as a whole. You also have presumably DNS or something equivalent. And I was wondering if you have thoughts on ways on how to securely bootstrap that set.
Yeah, this is a topic in our list, and we are thinking about how to choose wisely a subgroup of the overall servers in the pool. There are a few suggestions, like in technique that we can use in order to do so, and this is ongoing project. So if you want, we can take it offline.
Okay. Thanks, very interesting.
All right, thanks. Quickly, I don't think you signed this, so can you take, when you go back, and if anybody else hasn't signed the blue sheet, can you get it from her after she signs it? All right, so the next set of topics that we have are related to ref IDs and extension fields, and there's a whole list of drafts that are associated with them. So we're going to start with the ref ID topic. Hold on a sec. Let me see if I can. All right. So there is a current ref ID draft, ref ID updates, and I had a chance this week to speak to the authors of that draft. There are 3 proposed new ref IDs in that. And there are 3 proposed ref IDs, the not you, the IPv6, and the leap smear. There is actually a very recent, I asked for some reviews of this document, so this discussion might be a tiny bit premature because now we're getting some reviews on the list, which is what we need. The proposal that Sharon and I had talked about coming into this was to separate out the not you and IPv6, and I know, and I apologize to the working group that I'm the one that suggested we put all the ref ID updates in a single draft. But a year or so down the road, I'm thinking that was probably not the best idea. So we're thinking about separating out not you and IPv6 from leap smear and having the 2 pieces of work advance separately. Sharon is not going to be here today. She left last night. So with that, I'm going to, Harlan, you're up.
Thank you. I kind of don't care whether we separate leap smear out again. The content really won't change. These proposals have been around for a couple of years, and not you, and there was another one, the IPv6. There was a different, and there's a suggested ref ID also that corresponds to the not you, or is orthogonal or similar to not you. They're there. They've been around for a couple of years. These are options that people can use. We're trying to specify a mechanism here and let people use local policy choices to decide what to do. Not you basically means that there is no mechanism in NTP at the present time for a server to tell the other side, if you use me as your time source, this is the ref ID I want you to use. That's the purpose of the suggested ref ID proposal. The purpose of not you is that if I think I have enough information, I can let you know that you aren't my system peer. And that works great if it works. If it doesn't work, Sharon just made a change to this to make it more clear that there is a chance that I don't know something important, so I may say it's not you and it really is you. The IPv6 ref ID change comes from a report we actually had where the current MD5 hash of an IPv6 address turned out to look just like an IPv4 reference for a different machine in the provider's network. So the IPv6 ref ID change uses the first octet of 250 something, which is an impossible value for an IPv4 address, and that's the point of the proposed IPv6 ref ID. And the reason for the leap smear ref ID is that an increasing number of time servers are choosing to respond to client requests with smeared time instead of accurate time. And the last leap second, we had a situation where people who had configured 4 time servers lost sync because 2 of their upstream servers provided consistent UTC time, while 2 of them happened to offer smeared time, and there was no clear majority leader in a 2 versus 2.
Okay, Harlan. For what I'd really like to do, I think we've had the discussion about what these ref IDs are.
Okay.
a couple times. And so I think at this point, the first question for the working group is, should we separate the first two out from the third? And now I'm waiting for somebody to walk to the mic. There you go. Go ahead, Philip.
Hey, Arlen.
And actually, before you start, can I say one thing? So I think
what happened to suggested ref ID? Because I thought that was in that proposal as well. Not you and suggested ref ID.
There's a suggested ref ID extension field. Is that what you're talking about?
Probably.
That's down in the extension fields.
Okay, but it goes to the ref ID.
Okay. So the first step is, do we want to separate them out? And then the second step is, do we need the ones that are specified, and are they clearly enough specified to move forward? So, but go ahead, Philip.
Okay. A couple of suggestions. Just using 3 octets for the IPv6 hash seems like we're starting to spread things a little bit thin there. So my suggestion is fill the ref ID with all zeros and come up with an extension field that's actually big enough to accommodate IPv6. or better yet, and this is in my email earlier, have nonches negotiated between the two servers, and then use those nonches in hashing generating the hash of the concatenation of the nonch and the first and the second server, so the source and the destination. And then the reference IDs will be concealed to anybody but a direct man-in-the-middle attacker.
So are you advocating for the suggested ref ID proposal?
Well, like Karen, I'm unclear what the suggested ref ID proposal refers to. So if that's a separate document, I've not read it yet. And then the other thing that I was going to say is the whole leap smear thing. As we used to say at MIT, looks like a kludge on top of a kludge in a paper bag. And the reason is you're trying to solve something that's not really your problem. If there are hosts out there that don't understand leap years or leap seconds, then that's their problem to solve, not ours. The best we can do is provide them with the most accurate information we have, and they either do the right thing with it or they don't. So those are my 2 comments.
Okay. Go ahead.
Yeah, I'm going to second Philip on a couple of those comments. First of all, on the IPv6 ref IDs, those should really just go into an extension field. The proposal as it stands solves one problem, which is IPv4 addresses colliding with v6 addresses, but it also greatly increases the probability of v6 addresses colliding with each other. Now we have only 24 variable bits in there, which means that once there are 2 to the 12 v6 servers out there, there's a high probability of some of them colliding. So on the leap smear thing, so I've berated AGL over this before. That NTP already communicates when a leap second is in progress, and not when is it? So maybe not well, and there are some things we can improve there, but it communicates it, and that resolution from there is something that belongs in the implementation processing and not in the protocol. With that said, I think the cat's out of the bag on this one, and we're there are enough leaf smear implementations out there that at this point we just need to follow along.
Okay. Any other comments?
As Kenson, I would like to have the leaf smear information in the package. It would help. It would make it easier for at least the servers that are intentionally doing it to signal that they're doing so. And the leap seconds, they're so incredibly broken that any effort to make it work better, at least have us know better what's happening would be good. I don't know if they should go in the RefID, but it would be nice to have them somewhere in the packet.
Right.
If I may.
Go ahead, Harlan.
The reason why we didn't put the actual RefID in an extension field is that it becomes invisible. We need to, when someone sees a packet, we need to be able to easily identify what's going on through the base packet header, and there's a RefID field in there already. The same thing is true for ideas that says we want to tell people what the leap differential is during a leap smear in the extension field. It's invisible. And once the packet has gone by, there's no way to tell. But if I'm synchronizing, if my system peer is a server which offers a leap smear, when you run an NTP query against it, you're going to see the RefID that's showing up. And at that point, it becomes instantly obvious that my system, that system is following a leap smearing server. And even if you don't use mode 6 for that, if you use something else to say, hey, who's your system peer, it just works. And if people choose to not to follow leap smear, that's great. But at some point, you got to identify when it's happening. And you can't do that with an extension field, because if an implementation does not understand an extension field, it's supposed to ignore it.
Okay.
Philip again. Well, it's supposed to ignore it unless it's a required field. So why don't we just make it a required field?
You can't fix machines that are already out there. And is the short answer.
Well, sure you can. You apply an update to them.
You should look and see how many millions and millions of NTP v3 servers are still running today, 20 years after it's over. In theory, your idea is great. In practice, it doesn't work.
You've kind of defeated your own argument, though. I mean, if there are that many NTP v3 servers out there, then nothing that we do in this room really matters to them.
That's not true either. This goes about not making it worse. But I don't know that, if we want to, I'm all for taking this to the mailing list, because there's some other things I'd like to discuss here if we get to that point and have a few minutes.
All right, so Dieter?
Dieter, speaking as working group member, regarding this leap smear RefID, I mean, the RefID have a special purpose. Its purpose is to protect for timing loops. Using this field as a field to transmit leap smear information sounds for me that's more or less a workaround, but it's not from protocol point of view not a very good design, and we shouldn't do that from my point of view.
All right, so Doug?
Doug Arnold Meinberg. Couple of comments. A retired officer in the Army recently told me it takes 20 years for them to update equipment in their systems. So there are at least some specialized systems that have a very long time to be updated. The other thing is someone said leap smear is solving something that's not our problem. When you're running a leap smear, you're no longer running a standard timescale. That's not UTC or anything that's standard timescale. You're off on your own. So if we're going to do it at all, it's very important that be easy to recognize that this is a smeared time and not standard time.
Right. All right. So let me go back to the original question. I don't think there's any point in taking a hum. Is there anybody who's opposed to splitting this into two documents? No.
I'd rather not do the work if it isn't really useful.
I think the I think it will help the first two progress faster because I think the leap smear is going to be harder and more controversial, and it is currently confusing text that people are having trouble understanding. So I think it's just going to take more time.
Okay.
So I think if all three of them were at the same level of maturity, then that
They are. I guess it depends on your definition of maturity, but okay.
If all of them were at the same level of document maturity, but they're not. So we would like to separate them. And I also think the first two are a slightly different nature than the leap smear one. I think the leap smear is doing a kludgy thing with ref IDs, whereas I think the first two are, a reasonably standard. I mean, they're sort of in line with what ref IDs were envisioned for. So, well, it's kludgy, but it's replacing that. How do you use a field that's sized for IPv4 to specify some IPv6 information? I did like your thought about possibly using an extension field for that. I think there's going to be problems. Actually, I should have told you to go to the mic. I'm sorry. I just violated IETF process.
Yeah, mea culpa. Philip again. So, the other thing is we could say that from now on, ref IDs are required to be the same size as the transport the transport layer that you're running upon,
right?
Or the network size that you're running upon.
Not for NTPv4.
Because
the standard defines the ref ID field as 4 octets. Bang, end of story.
I think we really need to take this to the list. So, so we have a way forward for the ref ID updates. No. I want the correction field one. Miroslav, are you ready to talk about? So now we're at the extension field part of the agenda, and I've organized this in such a way that we have a extension field proposal that is 7822 compliant, and then we have a discussion of 7822 biz, and then we have a discussion of some additional extension field proposals that have been languishing for a while, waiting for us to resolve the 7822 biz issue. So, Miroslav, are you still online? Are you willing to talk about the correction field? And Miroslav, you might speak a tiny bit louder.
There is a new version of the correction field.
All right, go for it.
There were basically 3 groups of changes addressing some of the issues raised on the mailing list. One change is that the fields that correct the delay were shortened from 64 to 48 bits to not waste so much space, as was pointed out on the mailing list. 8 bits were cut from the beginning of the field and 8 bits were cut from the end. This means the resolution has decreased to about 1 picosecond and the maximum value is now just 128 seconds. A corresponding change to that was made in the receive and transmit correction fields. They are now only 8 bits long. In total, this saved 48 bits in the 28 octet extension field. From that, 16 bits were used to make the path ID and origin ID fields longer to make collisions less likely. And the remaining 32 bits were used for new correction fields to extend the route delay and route dispersion from the NTP header, similarly to the receive and transmit corrections. This improves the resolution from about 15 microseconds, which may already be a problem in current applications, to 1/4 of a nanosecond. Although the order of the fields in the extension field has changed, so all fields that may be modified in the network are together at the end of the extension field. I'm not sure if this makes a hardware implementation easier or harder, but I thought it looked better. This is all from me. Any questions?
Go ahead, Philip.
Yeah, Philip again. I have to say I don't understand the point of the checksum complement. Having worked for two different routing companies, I can tell you that recalculating a checksum when you decrement the TTL isn't that much work. You don't have to recalculate the whole thing. You have to convert it out of one's complement, figure out the delta, add the delta back in, and convert it back into one's complement, but you don't have to iterate over the whole header. So I don't have a problem with updating the UDP checksum. That this just seems extra unnecessary complexity for no real benefit.
They pack it completely in memory. They process it as a stream of bits. So they, at the moment, when the extension field is updated, the UDP header is already out. So there is already an RFC for the checksum complement. So this is just a generalization of that RFC, I think.
But then you end up with a modified packet where the UDP checksum is therefore incorrect, and the packet's going to be discarded by the receiving host, unless I'm misunderstanding something.
It's explained in the RFC.
Yeah, so I want to reply. Tom Mizrahi Marvell. I work for a chip vendor, and we're implementing checksum complements in PTP, for example, also in NTP, actually. And the reason for the checksum complement is that, like Miroslav said, you're often doing sequential processing, where you break the packet into a few chunks, and then you process each chunk and you send it. Okay, so by the time you get to the extension field, where you have the correction, the UDP checksum may already have been transmitted. Now, like you said, we still want the UDP checksum to be correct. So what we do, we use the checksum complement, which is actually the complement of the change we did in the packet, okay? So if we're changing, yeah, so if, right,
Can you
exactly.
use the microphone? Sorry.
We're assigning a new value which keeps the existing UDP checksum still correct. That's the idea here, and this simplifies or enables hardware implementations.
Okay, thanks. That makes things a lot more clear. Could a little discussion be added to explain that to somebody reading the document for the first
I
time?
think the current draft.
So,
points to
Miroslav,
the
did you hear
RFC,
Philip's
which
request to add some
explains
clarification?
The checksum complement detail, but
Okay.
yeah, we can explain it more in this draft.
Okay, thank you. Any other questions for Miroslav? So this is currently an individual submission. So the next question, this has been around now for a while. We've updated it a couple times. We will do we'll do a call for working group adoption on the mailing list. Given that it's 11:43, I'd like to just do that on the mailing list and not have a discussion about it here because we still have a couple topics, okay? So next we get to 7822 biz / extension fields. Harlan gave us a presentation in London on the updated version of the extension fields. We have not done a call for working group adoption on this yet. We've looked at a couple ways to move this forward. it still remains a somewhat controversial document. Philip, you're in the queue line.
Oh, well, yeah, I was just on Tracker, and I had problems locating that. Are some of the documents not named correctly, and that's causing them to not show up, or?
On Tracker?
Yeah.
It's I mean, I can double check while I'm talking. So there have so I guess the next step for this is to issue a working group call for adoption. Do we need to have any discussion on that in here? Okay. We are looking to find another editor to work with this document. So that is the one thing that that we may do as well. So is there any more discussion on this one?
Well, I sent some by email a little while ago, which you might have seen.
Oh, yes, I apologize. I meant to mention that we have had an email sent to the mailing list that takes a look at the extension fields. And I'll have to admit, Philip, I have not read the email yet. I just saw that it came in. So I think that would be one of the contributing factors on. I think we're at the point where we need to make a decision that we're either going to adopt this work and move forward, or whether we're going to hold off on any changes to extension fields until we do an update to the entire document set for NTP. And Philip is dashing back to the microphone again.
One general comment was, I thought it tried to address too many issues, and it could have been a little bit more targeted. And the other issues could be fixed in separate documents. Harlan, you want to reply to that?
Yeah, Harlan, you're still in the queue, so you can speak if you want, but.
I disagree, and I'm happy to talk about that offline if that would be more efficient.
Okay. So the next steps for this document is to do an on-list working group call for adoption. And that brings us to the next agenda item, which is the additional extension field proposals. And I do appreciate Harlan doing all of these. We currently have 4 additional extension field proposals that are in the data tracker. And these are, well, they're listed on the slide there. The question I had for you, Harlan, was I was willing to progress the ones that were basically 7822 compliant, and the ones that were 78 that required the changes to 7822 that you're proposing. I wanted to defer those until we had resolved the changes to 7822.
I would rather not do that because it's trivial to make a change to these should 7822 not get obsoleted, to simply throw some padding at the end of those. There's no reason I can think of to delay them.
Okay, so my perspective on that is we either update those drafts so that they are 7822 compliant biz, they are 7822 compliant and progress them, or we hold them until we've resolved the 7822 issue and then do new drafts. Do you see what I'm saying? I would rather...
If that's what you want, then we'll go ahead, and I'm happy is the wrong word. I'm willing to go ahead and throw language in there that says, I can find a way to throw anything in there that says any padding. We already know that extension fields can be arbitrarily padded with 0 bytes for any purpose. So I'm sure I can come up with language that'll address that concern. But I would really want to I really want these things to move forward.
Okay. My position is I think if we can move them forward, if they're written in such a way that they comply with the currently documented RFC.
I can take care of that.
Okay. Philip?
Karen, question. Sorry, I'm kind of
A disadvantage.
latecomer to the party here, but what's the rough consensus on 7822 bis?
There's a fair amount of opposition to it, so we need to resolve that. And it may be that some of the things that you've identified, I think some of the opposition comes from people that are unhappy with the changes that are being made, and some of the opposition comes from people that just don't really quite understand the text yet. So that's why I specifically asked you if you could take a look at it and work on it.
Sure, and I'll see if I can come up with some alternate language after consulting with Harlan that makes things a little bit clearer. So we have both existential opposition and just I don't get it.
We don't understand the rationale and the other thing that I had suggested to you is I really suggest you go back and look at the set of slides that Harlan did for the March meeting, because he put a lot of work into clarifying what he was trying to accomplish at that point in time.
Okay, so that explanation needs to be distilled into the next draft of the document.
Right.
Okay.
So is there anything else on this topic?
What do we need to do to move them forward or turn them into working group documents or something?
So the NTP draft STEN NTP extension fields, we're going to do a call for adoption on the mailing list, and we're going to take a look at, as part of that call for adoption, the comments Philip sent out today and any other additional comments that come in. So that's the status of that one. The other four need to be updated. If we want to progress them now, sooner is better, I suppose, then they need to be made compliant with 7822. So
how about if we turn them into working group documents sooner, and you're going to have those changes I talked about soon? I'm really...
Okay.
These things have been out there for years.
I can, if you're telling me you're willing to take the strategy I said, then I'm willing to turn them into working group documents. I will actually, by the way, I will apologize to the working group because I have caused a bit of confusion. I'll have to admit I started chairing this working group before Data Tracker existed, and sometimes I'm not really good at setting the status in Data Tracker because I don't look at it I don't look at the status very often. It turns out that other people do look at the status and they consider it very important. And earlier this week, I caused a lot of confusion because I marked a document as a candidate for working group adoption. I did that because the file name was named in such a way that it wasn't showing up in the NTP part of the data tracker because the NTP wasn't in the file name. That didn't mean that it was a candidate for adoption above all of these other documents that were sitting there. It just meant that I wanted it to show up in the right place in data tracker. So I will mark all of these as candidates for adoption, Harlan, and we can do a quick working group call for adoption on them.
Thank you very much.
So, and I'll try and do a better job of staying on top of data tracker. So it's what happens when you processes and tools change and you don't. All right, so that brings us to 11:53. Look at that. Any other business?
If we've got the time, I'd like to give a quick chat about the 3 proposals I submitted that I was hoping we would have a demo for over in the hackathon about secure network time as a better alternative to NTS.
You can have 3 minutes, and I want the last 2 minutes to wrap up.
Okay. The 3 proposals I submitted do 2 things. One, provide a means for NTP TCP services, which is a general mechanism to communicate with NTP in a way that is not limited by UDP packet sizes and the NTP rate limits. It includes a key exchange sub-proposal, the whole reason for which was simultaneously mentioned by the nice folks from NetNud, having to do with separating key exchange from the NTP server. The other proposal there is secure network time, which basically builds on the top-down architecture of NTP that says there's a black box between two NTP processes that does key exchange. And one of those is the symmetric key file. AutoKey was another one. And the other proposals do very similar things. The point being is if we can agree on a key ID and private, and opaque data, whether that MAC or HMAC or any other sort of thing gets deployed as a legacy MAC or as a MAC and an EF, it just builds on it and life gets easier. And the net result of this is secure network time out of the gate will support client server, symmetric mode, minicast, and multicast. And that in a nutshell is what these proposals were for. And I apologize that we were unable to come up with a working demo by the end of the weekend, but we're supposed to be very, very close on that. I'm done.
Okay, thank you. Just for the well, actually, I said this on the mailing list, so I guess it doesn't really matter. But the proposals are obviously welcome, but we do need more written detail, and right now there's not much there. So, all right. So to any other business? Nope. Okay. So to wrap up, next steps for the working group, we are pondering, or maybe it's me only pondering at this point, the possibility of doing another interop type of activity to progress NTS in various NTP implementations. The candidate right now is possibly the first week of October, and I'll follow up with anybody that might be interested in that. And then we're looking at, we have proven in the past, and we proved again, that we don't actually make a lot of progress unless we have virtual interims. So Dieter and I, mostly me, didn't do a good job of scheduling interims this time. So I've looked at the calendar. I've picked a couple weeks of opportunity. And so the objective at this point is to try and have 2 virtual interims between now and Bangkok. And hopefully by then, I'd like to be getting a lot of the little things that have been hanging around for a long time out the door. So anything else? All right. Well, with that, you have 3 minutes left in your day, in your an extra 3 minutes, I guess. Thank you all, and thanks everybody. Okay. Yeah, oh, and thanks all the online guys. That's kind of. No, not really.